Okay, next one was also from TFS. It was from Energy and Power Systems. It was number 11. Did not understand the concept of why the fuel should be heated to 1,000 degrees F. So this is an interesting question. This question was about taking some waste heat from some industrial process, which is in the form of flue gas, and heating it up by burning fuel. Now, the flue gas is already 1,000 degrees F. And the question is, what's going to be the final temperature after the heating based on a mass flow rate of fuel that's being burned that's at some initial temperature and has a particular heating value. So the way we go about this is the first thing we want to know is how much heat, how much energy is that fuel providing? So we do the mass flow rate of fuel times the heating value. And that gives us this number here, this 1.7 times 10 to the 9th. But as I explained in the solution video, not all of that heat goes into heating the flue gas. Why? Because the fuel itself is only 70 degrees. It's not at 1,000 degrees. So some of that heat has to go into just heating the fuel just to get it up to baseline. And then whatever is left over above and beyond that is going to heat the flue gas after all the fuel has burned up. So how much heat is going to go into just heating the fuel itself? Well, we can calculate that as well. We know the mass flow rate of fuel, we know the specific heat capacity of fuel, and we know how much delta T it needs to make up. It needs to go from 70 to 1,000. So we calculate that number, and that's the 6.5 times 10 to the 7th. Now you might say, okay, well, out of all of the heat that the fuel is going to provide based on its heating value, 10 to the 9th order of magnitude, this is only 6.51 times 10 to the 7th. And fair enough. So what percentage is this number that's going to go into heating the fuel itself as a percentage of the total amount of heat provided by burning the fuel? It's about 4%. So if you just ignore that, second line completely, and you imply this entire 1.7 times 10 to the 9th BTU to the mass flow rate of flue gas, you will overstate the final temperature by, well, you'll overstate the delta T by 4%. So instead of going from 1,000 to 4,270, it'll go a little bit higher. Will it go all the way to 4,480? Not sure. I'd have to do the math. Probably not. I feel like 4% is going to be close enough here. But yeah, I'd have to crunch the numbers to be absolutely sure. But more importantly, the concept there, right, of understanding why some of that heat is going into just heating the fuel just to get up to baseline. And then the rest is heating the flue gas.